Hello friends, very good morning. Myself Dr. M.H. Annaya, and in today's video we are going to learn about the section of a square prism which is cut by a section plane normal to VP and inclined to HP. Friends, this is how a square prism looks like. So it is a square prism having a square base, a square top, and on its lateral surface there are four rectangles. And friends, here in the question for today's video, it reads like this: a square prism of side 30 mm, side is 30 mm and axis 70 mm long, rests on a square base on HP. So there are two square faces, one at the top and one at the bottom. This is a bottom square face, this is the top square face. It is resting on HP. So the square prism is on HP such that one of the side of the bottom face. So there are four sides. One of them is normal to VP or perpendicular to VP. Or friends, for the same position, it can be stated that two of the bottom edges or the square base edges are equally inclined to VP, parallel to VP, or perpendicular to VP. So these are the different positions possible. Now friends, let us place this prism on HP. My palm is the HP, and obtain the front and top views. So in the top view, you will be able to see a square, and we commence the projection of this solid from the top view. So top view is a square and front view is a rectangle of the given height. So friends, I have marked the XY line, the line of intersection of VP and HP, and I have shown VP and HP indicating the first angle projection. Here friends, I am going to write down the top view of the prism, which is a square of the given side of 30 mm. So let me write down a square of the given side, and friends, this is a square of 30 mm side. All the four sides will have the same dimension. So I'll mark 30. And friends, here let us name these corners as A, B, C, and D. So A, B, C, D represents the square bottom face. So friends, here I have to mark the center. So I can just join the diagonals using thin lines, and we get a point here that I will call it as O, the center of the top face. And similarly bottom will also have a center, we'll call as O1. Friends, from the top view, let us obtain the front view of the solid. The front view is going to be a rectangle of height is equal to 70 mm. So friends, this is the front view, and this is obtained by projecting lines from here. And let us mark the center of the top and bottom faces of the solid. So friends, we can call the center of the top face as O dash, that of the bottom as O1 dash. This is the axis O dash, O1 dash, which is normal to HP. Friends, let me name these. So naming is very, very important. So in the top bottom face, I just marked A, B, C, D. So you will get here A dash. This is C dash, D dash. This is B dash. So A dash, B dash represents the top face. Similarly for the bottom, it is going to be A1 dash, B1 dash, C1 dash, D1 dash. That is the bottom face, is the top face. And here also, remember friends, for the prisms, cubes and cylinders, there will be double marking in the top view. So this is going to be A comma A1, B comma B1, C comma C1, and D comma D1. So in the top view, AA1 represents the longer edge here, CC the longer head, and so on. Friends, here let me mark this height of the solid as 70 mm, or the axis of the solid or height of the solid. All this mean the same. Friends, we have got the object resting on one of the square faces on HP. You have got the top view a square and front view a rectangle of the given height. Friends, now let's see how the solid is being cut. It says it is cut by a section plane. A section plane is a sharp blade like thing, a rectangular blade of line thickness, and it is going to cut this solid in such a way that section plane is what that is normal to VP. So whenever the section plane is normal to VP, it is seen as a line in the front view. So whether it is inclined to HP or parallel to HP, whatever be the situation, it is seen as a line in the front view. So the section plane is bisecting the axis, cutting the solid into two parts, and it is inclined at an angle of 45 degree. Friends, so I mark this center of this height at a distance of 35 millimeter from here. So this is 35, half the height of the solid, and here I am going to write down a section plane which is passing through this center and inclined at an angle of 45 degrees. So this angle is going to be 45 degree. Friends, I will mark this section plane as S and S. This is a sharp cutting blade which is cutting the solid, bisecting or cutting that into two equal halves. So after getting the position of the section plane, friends, you will have to mark the retained portion of the solid. So when I just cut it into two pieces, the upper piece above the section plane is thrown out, and whatever the portion that is remaining is shown by dark lines. So friends, in this question, we throw out the upper part above the section plane. This portion of the solid is retained for the purpose of getting the section. Friends, here, after we throw out, let us see where all the section plane is cutting the solid. So friends, as you observe here, this section plane SS is cutting the vertical edges AA, BB, CC and DD. So there are 4 points where the section plane is cutting all the 4 vertical edges of the solid. Hence friends, let us obtain those points in the top view one by one. Friends, when you start with the solid edge A dash, A1 dash, it is cut here. So A dash is cut here, and this is the corresponding point in the top view. Similarly, B dash, B1 dash is also cut here. So you will get the point here. So friends, whether it's cutting here or here or here, anywhere, both the edges are cut and you get the corresponding position in the top. Similarly, friends, CC is cut here. So CC is here. This is the point in the top view. DD is also cut here. So I mark this. Friends, I have marked the points where the section plane is cutting all the 4 vertical edges of the solid. And friends, now I am going to join all these by dark lines or visible lines. So this is the way we join these. So all the 4 points are marked and joined. So let us name them as 1, 2, 3, and 4. So 1, 2, 3, 4 are the 4 points. Let us mark them in the front view. 1 and 2 lie here, and then we have got 3 and 4 lying here. So I will mark it as 3 comma 4. Friends, we have got the top view, and after getting all those 4 points in the top view, and after joining them by straight lines in case of all prisms and pyramids, we are going to section that or hatch it by lines equally spaced and parallel to each other. All these lines are generally inclined at an angle of 45 degrees to the horizontal. It is just a convention, and these gaps between the parallel lines should be around 2 millimeter when you make it in a drawing. Friends, we have the front view here. The front view is this complete, and then these lines, what I have shown by dark, should be drawn by thick lines or visible lines, and all the lines above this cutting plane should be shown by thin lines, just visible to the observer. And friends, let us mark this as the front view, FV, and here you have got the square with hatching. This is called sectional top view. Top view along with this section, that is sectional top view. Friends, we have got the front view, you have got sectional top view, you have got, and we want to get the sectional side view. That is, how does the object look when the upper part is thrown away and it is viewed in the left direction, from the left end of the observer or to your left. Friends, what happens when you see this object from this left end? The image of that falls on the right profile plane. So the left end view which you are going to get, uh, left hand view, or you can say left side view, LSV, better. Left side view is obtained on the right profile plane. So how to obtain? It is very simple. So after getting these two views, I am going to mark a vertical line by name x1, y1, which is drawn normal to the xy, and this line is the intersection of VP and the right profile plane. Friends, I am going to get the left hand view of the whole solid, assuming it is not cut by any section plane. Friends, very obviously, when you have an object, a square prism like this, when you look from the front, you see a rectangle, and when you look from the end, you see this rectangle. So it is seen as a rectangle in both the front and end view. So friends, I draw a line here, a horizontal line through this top end, and here I write a line at an angle of 45 degrees to obtain the so-called the end view. Friends, this will cut the 45-degree line here. So friends, I am going to get vertical from here and get what is the side view of the object. So the side view, so this, to start with, let us write down all these by thin line. Then after getting the complete projection, we can darken the remaining edges. So friends, here I have shown the left hand view of the solid, assuming that it is not cut by any section plane. Friends, let us mark the vertical edges and the base and top edges. So friends, here on this line you have got A and D. So this is going to be A double dash, this is going to be A and D, D double dash. Here you are going to get B double dash C double dash in the end view. Similarly, for the bottom portion, we call this as B double dash 1, that is C1 double dash. This is A1 double dash and B1 double dash. We have the so-called the axis, which is O double dash comma O1 double dash. So we have got the object in the end view, assuming that it is not cut by section plane. Friends, onto these vertical edges, let us transfer all these points obtained in the front view. Friends, here 1 is an AA. So I am going to draw a horizontal line from 1 so as to cut AA. Similarly for BB, also it is cut here. So I will mark this point also. Likewise friends, this is 1, this is 2, and friends 3 and 4. Draw a horizontal line from there and obtain these two. So friends, we are getting the point 3 on CC, point 4 on DD. We have got the 4 points in the end view, and friends, whatever the points you have got, join them by straight line. So 1 to 2, 1 to 4, then 4 to 3, 1 to 2. Friends, this is the portion that is seen there. And friends, below the section plane, all the base is retained. This much of height is also retained. So I am going to extend these lines and mark the end view. Friends, the portion 1, 2, 3, 4 is to be hatched. So I am going to show the sectioning for the portion 1, 2, 3, 4. Friends, you can just see here, if you visualize this is how the object looks. So this is our 3 and 4. This hash portion is this black portion, and this line 1 and 4 is this, and this is the base of the solid. That is, after removing this piece, this is how it will look in the front view. That is this portion, and in the end view it will look like this. And this black portion of the solid is the cut section of the solid. And friends, here above this point, because the portion above 3, 5, above 1, 2 is removed, so this much of portion is to be shown by thin line. And the complete figure here is called LSEV. LSEV means left sectional end view. That is the left end view along with the section. Okay, that's LSV or LSEV. And friends, we have got the front view, we have the top view, we have got the end view in section. Finally, the small portion is left over. What is the true shape of the section? Friends, what is the meaning of true shape? True shape is the mirror image of the cut portion of the object. Friends, for example, you have this cut section, as you can see, and if you hold a mirror parallel to that section, the mirror image of that cut section is the true shape. Friends, very obviously, when you hold a mirror parallel to this rectangle, you are going to get a rectangle of length is equal to so much and height this much. So this is the true shape. So true shape is going to be a rectangle with length is equal to side and height depending on the inclination made by the cutting plane. Friends, here let me mark a line parallel to the section plane SS. So, friend, I am going to mark a line here that is perpendicular to SS through the point 1 and 2. So, this is one line. Similarly, from here, I am going to draw another line. So I have drawn these two lines perpendicular to SS, and you just have another reference line parallel to this at any convenient distance. So this line is parallel to this. Friends, here I am going to mark these 4 points to get the true shape, which is a rectangle, and I have already shown this. Friends, look here, how to get these points on this. Friend, always you should measure the distances of the sectioned part, whether in the front view or in the top view, from XY. So point 1 is here. You measure this distance on mark on this. This is point 1. Similarly, 2 is here. From XY up to 2, measure that and mark here. This is going to be point 2. You got 1 and 2. Friends, similarly, 3. The point 3 is here at a distance same as that of 2. So simply you can write a line here and obtain that point. That point is 3. Finally, 4. 4 will be exactly opposite to 1 here. So friends, we have got 4 points here. We will join all these by straight lines. So 1 to 2 I have joined, 2 to 3, this is 3 to 4, and we have finally 1 to 4. Friends, if you have this parallel to or at an angle to XY, at an angle of 45 degrees to XY, this is how you see this section, that is true shape of section. This we call it as TS. TS means true shape, and very obviously it is going to be a rectangle. Rectangle. The name of the true shape is rectangle. Friends, here there are some very salient points to be remembered by every one of you. What is that? Friends, here you can see this distance 1 to 2 is equal to 30, and very obviously 1 to 2 is equal to 30. And friends, this distance 2 to 3 is the same distance. That is, whatever the distance you have in the front view, 2, 3 is that distance. So friends, there can be a problem on the same square prism. Given the true shape of section, obtain the position of the section plane. Is it possible? Yes, it is very simple. Friends, 1, 2 is this distance, 1, 2. And similarly, this 2 to 3 is that distance. So what we can do here, we can have the position of this 2, 3 or the length of this 2, 3 equal to this gap, obtain the position of the section plane. So in the next video, I am going to work out a problem on the square prism wherein the true shape of the section is given to you, and you will be asked to find out the position of the section plane, that is at what height or at what angle the section plane is cutting the solid. Friends, I hope you are happy with the presentation, and if you like my presentation, please give a liking, share this information with all your friends, and have a wonderful day.